So a couple administrative items to begin today. First of all, a reminder that problem set 3 is due Tuesday. You probably don't need the reminder, but if that slipped your mind, there's the reminder. Also a note, Jeff has accumulated some uncollected problem sets 1, 2, and perhaps a quiz. So he has those here. If you somehow neglected to get those previously, see Jeff up front here after class, and he'll be happy to share them with you. The third note I have here, we talked about study groups. Some of you have emailed me recently indicating that you are missing a study group. If you emailed me in the last few days, I sent you back an email this morning. Whether you emailed me or not, if you feel like you want to coordinate with others to find a useful study group, I'm going to suggest that anyone who's sort of in that club meet at this sort of a podium just outside the lecture hall. So I'm going to suggest that right after lecture, anyone who wants to mingle with other students interested in studying, meet by that thing, and you guys can make the appropriate arrangements. If you continue to struggle finding a study group, be sure to let me know. I think it's important for you all to be learning from each other as well as from me and from the GSIs. Okay. Other questions about administrative matters? Okay, let's go ahead and get started. So I'd like to begin today with a picture of a economist, John Cotilla, who he's dead now, but he died only recently. He is well known among environmental economists for setting out a very important view in a 1967 paper in the American Economic Review, which is one of the leading journals in economics. They laid out the idea that individuals derive utility, and it was important to account for that utility, not only from the kind of private goods that we've been talking about, food and clothing and coffee and so on, but also possibly from the mere existence of a variety of natural amenities. So here's what he said. When the existence of a grand scenic wonder or unique and fragile ecosystem is involved, its preservation and continued availability are a significant part of the real income of many individuals. So he's laying out this idea that there might be a national park, and you might derive utility because you go to the park and hike around. That's one reason you might enjoy having national parks. But it might also be the case that you simply like knowing that national parks exist, or wilderness areas, or what have you. And so this is sort of this article lays out sort of the first formal attempt to integrate that kind of the idea that the existence of an environmental amenity or other good has an impact on people's utility that ought to be accounted for in our conduct of public policy and so on. So I'll return to that a little bit, the idea of existence utility a little bit later in today's lecture. I'll say a little bit more about John Cotilla. This is an important article. He also was the founder of an institution called the Resources for the Future, which is sort of a Washington, D.C. think tank that he set up in the 70s that when it was created and still employs a fairly large number of economists to do research on natural resource and environmental issues. They're sort of probably the leading think tank involving economists that works in environmental topics, I would say. Sorry, Resources for the Future. It's abbreviated RFF. Okay, let's see. All right, so let's go ahead and get started. So I want to start today by talking about discrete choices. So we spent quite a lot of time, well, actually we started by talking about the discrete choices that different people might make. So we had silly cases where I'd say, well, would you rather have 3 cups of wine and 1 cup of coffee or some other bundle? And those sort of preference ordering things we did involve discrete choices. Do you want bundle A or do you want bundle B? Since then, we've moved into a world where we usually assume things are discrete, and we're using calculus to try to solve for consumer demands. So we'll say, well, how much of X1 or X2 do you demand? And we generally have been assuming that those are continuous variables. So there's nothing discrete about the choice that you make when you decide about how much X1 versus how much X2. It's a continuous thing, and we want to put continuous-looking indifference curves, and we can use calculus to solve the problem of making choices over this kind of continuous variables. Okay, nevertheless, a lot of the kinds of decisions that consumers make have a sort of indivisible or discrete character to them. And I want to sort of go back and relate the work we've been doing on choices over continuous variables back to sort of the discrete case. Here's some examples. Vanilla or chocolate. If you're constrained to have one ice cream cone and you can only have one flavor, you have to choose vanilla or chocolate. You can't go to the ice cream store, I think, and say I'd like a scoop of ice cream and make it 0.86 vanilla and 0.14 chocolate. So far as I know, nobody provides that service. Although if there was a demand for it, I suppose they could mix it up. A more serious and sort of pertinent choice, I'll return to an example. Where to live. Different cities or cities versus countryside offer different kinds of amenities. The prices you face in those places may be different. The country you choose to live in involves a set of amenities, a set of prices and incomes that are different. And when you make a decision about living in one place or the other, it's very difficult and expensive to try to live in both places at once. So that's sort of a discrete choice. Yes? Oh, thank you. Here's the third one is I'll return to in a later lecture, purchasing indivisible consumer durables. So we've talked about cars, for example, and how they yield a continuous quantity of transportation services. So it's nice to be able to work with continuous transportation services for a lot of consumer problems. But when you go down to the used car lot and you want to get some transportation services, you may still have to make a choice between buying a Toyota or a Honda or whatever. Those are discrete choices. You can't buy half a Toyota and half a Honda, at least not easily. Decisions that you people have made have involved a decision about whether to spend your time pursuing your education in school or going to work full-time. So that's usually not entirely a discrete decision. Actually, how many people here work part-time? Okay, so number, how many people work full-time? Okay, good. So there may be possible to mix that up a little bit, but you sort of make a decision when you go to college, for example, about, well, I'm going to be a student or I'm going to go out and try to make a living. So that's a kind of discrete choice as well. Okay, so there's a general approach to trying to think about how consumers solve these discrete choice problems. And the basic idea is to figure out so think about the discrete situations. For simplicity, we'll think about them in 2. So let's take the school work decision for a moment. Say what you might do when you think about the decision is say, well, gee, if I go to school for another 4 years, my income will be really low, and I'll face some prices, but there will be some amenities, which might include, just like being a student, that might include the prospect of higher future earnings, stuff like that. So you can think about what your indirect utility would be when you're a student, and sort of then you can take off another hat. So, gee, if I didn't go to school and took a job, I'd have higher income, I'd face these prices, I wouldn't get to enjoy the amenities of university life, and you compare one indirect utility function to the other, with the same function, but evaluated as different arguments, and see which one of those 2 things gave you the greatest utility. Okay, so I'll go through a little example of that. So the general approach, though, is think about the discrete situations you're considering, compute the indirect utility function in either case, and see which one is bigger. Okay, that's the general approach today. Okay. All right, so here's a proper example. So let's make a locational decision instead. So let's imagine you're out of school now, and you're trying to decide whether to live a bucolic life in the countryside or a life in the city, for example. Okay, so we'll think about a particular consumer here. He's going to have a very familiar-looking direct utility function. This is just this logarithmic function we work with a bunch now. we talked last time about how to compute the indirect utility function for a direct utility function like this. And I don't recall if I gave exactly this formula. I think I gave a special case where alpha is equal to 1/2. But here's the indirect utility function for a person in this situation. The indirect utility for this person is going to depend on prices and income. It'll be equal to the log of income minus alpha times the log of P1 minus 1 minus alpha times the log of P2. And then there'll be a constant. I'm calling it capital A here. Capital A just depends on the parameter. It's a function. It's a nonlinear function of the parameter alpha. And because it's a constant, I'm usually going to kind of ignore it. I'll sweep it under the rug. It's not very interesting since it doesn't depend on any of the behavior of the consumer or whether they live or anything. Just a constant we're going to add on to utility. Okay, so this is the indirect utility function for a person who has this direct utility function. Okay, is that clear? Okay, all right. Does everyone remember what an indirect utility function is? Say a little louder. And remind me of your name. Cassia, thank you. So Cassia gives, it's not quite the definition, but it captures the key idea, which is that the indirect utility function is the utility you get from having an income y, given that you face prices p, given that you make the optimal decision about what goods to purchase given those prices. And that's the interpretation of the indirect utility function. So once you know, so the indirect utility function, I think I said last time, is the answer to the question, how happy can a person be if they've got income y and face prices p? That's the answer to that question. Okay, so let's go on. So here's, I'm going to go back to this city-country idea. So here's the crude example. The consumer is trying to decide whether to live in the city or the country. And I'm going to assume that the price of X1, maybe that's food, is higher in the city than it is in the country. Yes. Yeah. No, because no. If you work it out, you'll see. If you work it out from this, it's a good question. If you work it out from this, you're going to wind up with a term involving alpha times log y plus a term 1 minus alpha times log y. So you add those two things up, and you get 1 log y. So I use this utility function or variance of it a lot, and part of the reason is because even though when you do sort of solve the consumer's problem for this, sometimes it's a messy algebra. At the end, it's almost always beautiful and simple. So that's nice. Beautiful and simple is desirable here. Okay, yeah, thanks for the question. All right, so the idea is that we're going to face prices in the city, which we're going to call P prime. So this P prime here is, think of it as a pair of prices for good 1 and good 2. And the assumption is the price of X2 is the same in both places, but the price of food in the city is higher, for example. So P prime is, P1 prime, if you like, is larger in the city. On the other hand, the income in the city is higher. You can make more money working in the city than you can in the country. Demand for labor in the city is higher than it is elsewhere. So you need to you face a trade-off. You can live in the country and get a low income, but also face low prices for food. Or you can live in the city, get a high income, but face higher relative prices for food. Okay, so you could live in the, I'll this, Chris observes you could live in the country and commute to the city, or vice versa, I suppose. That's a possibility, but commuting is costly as well. That's a point I'll return to later, actually, not this lecture, but later. Wes? Yeah. Yeah, commuting is important in a lot of environmental problems, and so we'll actually return to that in a lecture or two. Right now, you're going to live and consume in the same place. Live and work and consume all in the same place, so it's really there's no trade-off there. Pardon? Oh, yeah, no car. That's right. The car's coming up later. Okay, so in this case, we're just trying to decide whether to live in the city of the country. And the decision for the person deciding this is going to be to ask herself, well, what's my utility if I face prices P prime in the city and get income Y prime in the city? That's my utility there, versus the utility I get in the country, where I face different prices and a lower income. And so she's going to ask, well, which is higher? And if V of P prime Y prime is larger than V of PY, she'll choose to live in the city. She'll be a city dweller. Yes, sorry. So the question of whether this is a good question. So Hillary asks whether or not this inequality should be a strict inequality or not. My answer to that is I don't really care. If it's equal, she's going to be indifferent between living in the city or the country. So we may as well just assume she lives in the city. I don't know. We need a little tie-breaking rule. That's not such an important distinction. Okay, other questions? Yes. It's prices. Let's see. Oh, is there something I say that's wrong there? So yeah, in the equation, it's prices and income. Prices in the city, in the country are P and Y. P prime is prices in the city, and Y prime is income in the city. I think I got everything. Okay. Let's see. Oh, hold on. So maybe I'll solve this for you quickly if there's demand for the particular example utility function. Although it's very direct. Am I in danger of boring? How many people would like to see that? Okay, I think that's. I don't know. How many people would not like to see it? Okay. So a lot of you actually are indifferent between seeing the case and not. Let me do that algebra for you just really quickly. So all I'm going to do here, and this really is quite immediate, I'm going to use the formula I just had here before for the indirect utility function. And so the utility we're going to have in the city is going to be this V of P prime Y prime, which in this example, this utility function, is equal to the log now of Y prime minus alpha times the log of P1 prime is the first price in the city, minus 1 minus alpha log of P2. And remember, I'm assuming that one's the same, so I'm not going to put a prime on this one. And we're going to ask whether or not this is greater, plus A. We're going to ask whether or not this is greater than or equal to the country utility. That's going to be equal to log of Y minus same alpha log of P1, so regular P1, not P1 prime here, minus 1 minus alpha log P2 plus A. This is all just equal to V of PY, and this is the country utility. Okay, so what I want to do now is ask when somebody's going to choose to live in the city, when this person's going to choose to live in the city. So I'm going to ask when this inequality is satisfied. And so immediately I can make some simplifications. Does anyone see what some of those are? That's right, the A cancels. That's why I sort of, when I slide a moment ago, I said I don't care so much about A. It's never going to matter if it's a constant, because whenever you make these comparisons, it's just going to go away. What else? Yeah, the prices for the second go to the same in both places, and those only occur in this additive way for this utility function. So this is going to go away. This is going to go away. You may. The price of x2 will assume to be the same, in parentheses there in the first paragraph. Okay, or I can put it back on the slide. Okay, so we've got now a simpler expression. So we'll live in the city if we have the log of y prime minus alpha times the log of p1 prime is greater than or equal to the log of y minus alpha times the log of p1. And we can make that a little more beautiful also. So I'm just going to rearrange stuff here using the magic of logs. So I'm going to say we're going to live in the city if the log of y prime divided by the log of y. So somebody interpret that for me. What is it? So the ratio y prime over y is your city income divided by your country income. When we take logs, it's approximately the percentage by which your city income is larger than your country income. That's an approximation. We'll come back to later on. And that'll be, so we're going to go to the city if this quantity is greater than or equal to the, alpha times the log of, let me get this right, yes, p1 prime over p1. Okay, so I just added this alpha log p1 prime to this side, and then used the magic of logs to turn it into this kind of expression. And so this again is, this log of p1 prime over p1 is what, approximately? That's actually not quite. It's just, without the alpha, it's approximately the percentage by which the price of good one is greater in the city than it is in the country. Okay, so it's again roughly a percentage difference. So if it's food, you might say, okay, food's 20% more expensive in the country than it is in the city, for example. And then alpha is, what's the interpretation of alpha for these references? Yeah, it's the expenditure share for that good in this consumer's budget. So what Eric said a moment ago was not quite right when I asked about log of this thing, but when we multiply by alpha, this is the increased cost of living in the city as a percentage, on a percentage basis, and this is the increased income on a percentage basis. So this person's going to choose to live in the city if this thing's satisfied. So what kind of people are going to tend to live in the city versus the country? Okay, so Wes says people who have smaller alphas will tend to live in the city. That's good. So the interpretation there is people who don't care so much about the good that happens to be more expensive. Okay, that's good. What other? Yeah, so Eric said, well, almost. It's people who have a disproportionately large income in the city. If you have a large income both in the city and in the country, this would just cancel out. So it's if the returns to the kind of labor you provide or your services or your profession or whatever are much higher in the city than they are in the country, well, this is going to tell us what's sort of obvious once I put it that way, which is that you're going to be more likely to live in the city. All right, so that's the discrete choice problem. There's a couple nice things you can do here that are related, I think, to a problem on the problem set. You can ask, for example, what the critical value of alpha would be for someone to be just indifferent between. So what's the largest? We said people with small alphas will tend to live in the city. You might also ask, well, what's the largest value of alpha for somebody with a fixed income here to live in the city versus the country? So you can solve that by setting this to make it be inequality and then solve for alpha as a function of that other stuff. You can also fix alpha and mess around with the y's, see how large the income increment has to be in order to get you to live in the city. Okay. All right, questions about that example? Yes. That's because I just produced it. I pulled it out of a hat this lecture. I went through it more carefully last lecture, and the trick. So I'm not going to reproduce it. I'll tell you the trick in brief. I mean, the way to get the indirect utility function, or one way, the way we talked about, is to do the following steps. You solve the consumer's problem of maximizing utility, and from that you get Marshallian demands. Second, you substitute those demands into utility, into the direct utility function. So you get something like this. You get v of py. It's equal to u, which is the direct utility function, evaluated at, say, x1 of py, x2 of py, where these x1 and x2s are the Marshallian demands you got in step 1. And then step 3, actually, is also sort of important and related to the point that Taishi, sorry. And then we simplify, because what you get out of this if you just do the substitution is a little messy. Okay, other questions? But look at the example in the slides from last lecture, which should be on space. Yes, Wes? No, you're just holding your copy. Okay, other questions? Let's keep going then. All right. Okay, this will be fun, I think. So we've talked. The indirect utility function tells us something really nice. So it tells us if a person faces prices P and they have income Y, and I haven't said this before, and then they can purchase all the goods that they value, all the goods that enter the utility function, then the indirect utility function tells you how happy they'll be. And there's a problem that comes up, and it's particularly acute when we think about a lot of environmental problems, which is that not all the goods that people value can be purchased, so that there may be non-market goods. And so we want to be able to think about that. We don't want to just throw up our hands. We can grapple with this, but we need to think about if our utility is affected by, if our happiness is affected by goods that individuals can't